Alright, here we have an input module. Now, input modules come in three basic types. There's digital, analog, and specialty modules. In this case, it's going to be a digital module. And the voltage will be 120 volt AC. And the thing we notice about our modules, we have terminal strips. Now that's going to join the field sensor to the electronic circuitry and the power supply. That's the function of the terminal strips, and you can see we have input 1, 3, 5, 7, 9, 11, 13, 15, and our AC common. Now we're missing the other side. I didn't draw it in. This is just for illustrative purposes. So here, our field input, we're going to have a proximity sensor, and our power supply, again, will be 120 volts. So we'll connect that up to the terminals. That'll be line 1 and our neutral down here. Now we can see that only part of the circuit's hooked up. We need to hook up the internal circuitry. Why do we need to do that? Because the CPU doesn't like 120 volts AC. It typically runs on 5 volts DC. And it needs a nice clean circuit. So we'll give it a nice clean circuit. So part of it is we need to rectify it down to DC, and we'll do that using a bridge rectifier. So we'll put in our diodes. Of course, we don't have to do this. This is internal. But it's a good idea to know how this whole thing works. So there's our bridge rectifier taking the AC, and we'll convert it to a DC over here. And this part comes out, and of course we need a current. This will limit the current and voltage coming up. And of course this is simplified. There's more to the circuitry than this. And it's going to go to an LED. Now the reason it goes to an LED is we want to limit the effect of voltage transients caused by the contact bounce and or electrical noise. The CPU, which is going to be over here, is extremely sensitive to voltage spikes and electrical noise. We want to filter it, so we don't want any transients to produce false data. Alright, so we'll continue drawing this. It gets connected up over here, and of course it comes through here, comes up over and down to our AC common. Now I could stop there, but we're going to complete the circuit. You can see it actually comes through, and for that matter we'll take this. So you can see it is in fact one big circuit. Now why do we have our LED here? Well, we want to optically isolate it, and so it gives it a nice clean, so there's again for our voltage spikes and electrical noise. So over here on the CPU side, we're going to use a photo transistor. So it'll optically connect this circuit to this circuit. And again, this circuit here would be 5 volts DC. That's what the CPU looks like, and this cleans it all up. And there's one other feature on the input module. Now, when this closes to complete the circuit, there's going to be an indicator light, and that indicator light will correspond with the input. In this case, it's input 1. So when this closes, this light will come on, and we know that it's connected.